Hey everyone. Alright, today's video is going to be over estimating irrational numbers. Your objective, I will be able to estimate the value of an irrational number. So let's do some review. A perfect square is the square of an integer. For example, 1 squared means 1 times 1, and that is 1. 2 squared, 2 times 2 is 4. 3 squared means 3 times 3 is 9, and so on. So when we find a square root, that's just the inverse of squaring a number. For example, if 4 squared equals 16, then the square root of 16 equals 4. Now, this could be a positive or a negative 4, because if we took negative 4 squared, so we would have a negative times a negative, we would still get that positive 16. Now, you don't have to list that negative unless it specifically asks for it. So just list the positive unless otherwise noted. Okay, what I want you to do right now is I want you to write down all the squares from 1 through 20. So go ahead and pause and get all of these copied into your spiral. Okay. Let's do a few examples. Letter A says we want the square root of 64. Well, if you don't already have that memorized, you can check your chart and you can see that the square root of 64 would be 8. Okay, letter B wants the negative square root of 121. Again, on your chart, you can see that 11 squared is 121. So the square root would be 11, and here it specifies it wants the negative 1. So negative 11. Okay, letter C, we see a fraction inside of the radical. So we're simply going to take the square root of the numerator and take the square root of the denominator. So the square root of 1 is 1, and the square root of 81 is 9. All right, so now let's talk about irrational numbers. So an irrational number has a decimal form that does not terminate and it does not repeat. So it cannot be written as a ratio. The most popular irrational number you've probably heard of is pi. Okay, its decimal form goes on and on forever and it never repeats. Now, the square root of the non-perfect square is also irrational. For example, the square root of 10. Okay, there is no number that is multiplied by itself to give us 10, so the square root of 10 would be irrational. So that is why we are talking about those perfect squares and square roots today, because we are going to focus on estimating what the square roots are of non-perfect squares. Alright, so whenever we estimate square roots, the very first thing we're going to do is we're going to find the two perfect squares that the number lies between. So, like I put on the previous slide, the square root of 10, I'm going to work with that while I go through these steps. Alright, so the two perfect squares that the number lies between. So, if we were to square two numbers, like 3 and 4, that would be 9 and 16, okay? So 10 lies between that 9 and 16. And then we're going to write the square roots of both of those numbers. So I already did that, the 3 and the 4. And I'll put the square roots up here as well. All right, now we're going to circle the closer integer. Okay, now up here we see that 10 is closer to 9. So that means that this number is going to be closer to 3. Now we're going to estimate it to the nearest tenth by using halfway as the benchmark. Now, whenever we write this number down, we want to make sure it's a number that if we were to round it, it would round to 3, not 4. So I'm going to say 3.1. Okay, 3.1 would be rounded to 3. You could have said 3.2 or you could have said 3.3. Now, 3.5 would not work because if you were to round 3.5, it would round up to 4, and we know that we want our number to be closer to 3. So this would be a good estimation for the square root of 10. All right, let's do some examples. Letter A, we have the square root of 45. So if we look back at our place value chart, we see that 45 lies in between 36 and 49. So I'm going to write that down. Okay, now the square roots of those, we have 6 and we have 7. Now 45 is going to be closer to 49, so I know that I want my answer to be close to 7. So I'm going to say about 6.7, because if we were to round that up, it would round to 7. If you said something like 6.8 or another one, that's fine. It just has to round to 7. All right, letter B, we have the square root of 199. So again, let's go back to our place value chart. Not place value, perfect squares chart, sorry. All right, 199, that is going to fall between 196 and 225. So I'm going to write down those numbers. Now the square root of 196 is 14, and the square root of 225 is 15. Now, 199 is closer to 196, so I want my number to be closer to 14. So I'm going to go with 14.2 on this one. Again, if you put 14.1, 14.3, 14.4, those are fine. You just can't do 14.5 because then it would round to 15. All right, now we have 8 times pi. Now, we know that the estimated value of pi is 3.14. So that is, if we were to round that, that would be 3. So we're just going to take 8 times 3. So 8 pi is going to be approximately equal to 24. Now, this is different than letters A and B, but we are still taking pi, which is an irrational number, and we are approximating it to 3. All right, example 2. Tanya has a garden in the shape of a square. The area of a garden is 91 square meters. Estimate the length of the sides of the garden. So remember, for the area of a square, you are taking one side and you are squaring it. So area equals a side squared. So if the area of this garden is 91 square meters, that means we are trying to find the square root of 91. Now that is a non-perfect square, so let's go back to our perfect squares chart. Okay, and we see that 91 falls in between 81 and 100. So I'm going to write down the square root of 81 and the square root of 100. So the square root of 81 is 9. The square root of 100 is 10. So I know that this estimation needs to be between 9 and 10. Now 91 is closer to 100. So I know my answer needs to be closer to 10. So I'm just going to say 9.7. Okay, now it is time for you to try. So I'm going to write down a couple of examples for you. So the first one that I want you to do is I want you to find the square root of 38. I want you to find the square root of 200. And I want you to find 5 times pi. All right, make sure you have all of your notes written down and make sure you bring them to class with you so I can check them. All right, have a good day and I will see you in class.